Thanks for joining. This is Nathan Nichols, Marketing Coordinator for MetaScale. I have Andy McNalis, Hadoop Infrastructure Specialist here today, talking about making a case for Hadoop in your organizations. For the past 3 years, Andy has been heavily involved in implementing Hadoop in the enterprise at Sears Holdings. Before that, he spent 7 years as a data warehouse manager. Before I pass things over to Andy, I just want to make a note that when you registered, you should have been able to access the white paper that corresponds to this webinar. If you did not get that link, don't worry, we'll be sending it following the webinar as well. Also, we'll try and make this as interactive as possible, so if you have any questions, please type them and send them in to us at any time, and we'll answer them as many as we can as we go along. So with that, let's kick things off with Andy McNalis. Andy.
Hello, everybody. Welcome to Making a Case for Hadoop in Your Organization. I wrote this white paper just as kind of a tool for folks that would need to create a business case or get approval within your organization to move forward with Hadoop. This first slide is really just kind of a quick little overview. Again, I work for Sears Holdings Company, but we actually offer Hadoop managed services through MetaScale, and we might talk a little bit more about MetaScale at the end of the presentation. But again, we leverage the knowledge and skills that we've been able to gain through our Sears Holdings efforts through MetaScale to customers. Again, what is big data and what is Hadoop? Really, these are more or less my definitions. Big data is data that you can accumulate from a single source that is larger than a traditional either relational database or data warehouse infrastructure could process or store in a cost-effective manner. So it's where you're talking about hundreds of terabytes or even into the petabyte range. And of course, with that volume of data, you want to be able to process it, and that's where Hadoop comes in. Let me go to the next slide here. So Hadoop is a open source software package from Apache. It is designed to run on a grid of computers. And the graphic that you're seeing here sort of shows 3 logical layers of equipment that Hadoop runs on. So the first layer is the client layer, and that is, in our reference architecture, where all users or jobs run is on that client layer. The next layer down is the masters layer. This is really kind of the brains of Hadoop. You've got your name node, which keeps track of where all the data blocks reside within a Hadoop cluster. A secondary name node, which isn't a failover name node, but it is kind of a backup to the name node and can be pressed into service if the name node fails. And then there's the job tracker node, which really keeps track of all of the jobs that would run against and consume the data within a Hadoop cluster. And then below that is the slaves layer, which is where all the data resides. Each slave has a data node and task tracker service that runs on it. And just real quick to go through an example, if you're writing, say, a terabyte file into a Hadoop cluster, the data is broken up into blocks, and they can either be 64 megabyte blocks or 128 megabyte blocks. And the Hadoop ecosystem handles breaking the data up into those blocks and placing them across the available data nodes in your cluster. The name node actually keeps track of where all the data blocks reside. And then in addition to that, you can set a replication factor within Hadoop of either 2 or 3. You might even be able to set it to higher, but in our clusters, we've set it to 2 or 3. And Hadoop automatically replicates those blocks for fault tolerance and redundancy purposes. If you set the replication factor to 3, one of the things that Hadoop will do for you is that it'll actually replicate a block on a machine in the same rack, and it'll replicate a block into a different rack. So you actually have fault tolerance across your cluster. So basically, you could lose an entire rack, but your processing will continue because Hadoop handles making copies in different racks for you. So that's kind of a high-level overview of Hadoop. Let me hit the next slide here. So uses for Hadoop in the enterprise. This is pretty much how we've utilized Hadoop within Sears Holdings. So Hadoop has traditionally been used for unstructured data, and that's pretty much how it began for the most part in Silicon Valley, is a lot of the internet companies would capture a lot of clickstream data as well as screen data and pretty much just kind of dump it into Hadoop for analysis purposes. We do have some unstructured data in our environment, but we also have a lot of structured data in our environment, which I'll get into in a few minutes. Obviously, we use our Hadoop cluster for processing big data. So, again, this is where you've got hundreds of terabytes or into the petabyte range of data, and you need a cost-effective place to put it. So that would be your Hadoop cluster. We also use our production Hadoop cluster as an enterprise data hub, for which I've got a graphic here. Let me go to the next slide real quick. So our enterprise data hub, we've got an entity relationship diagram defined by subject matter, and we try to take data directly out of the operational systems that produce this data and put it into its most rawest form in the enterprise data hub. And a lot of the benefits to that are that you get your single point of truth. Also, any application that needs the data can go at it in its rawest form and make any transformations that they need to it sort of on the fly. And that kind of processing actually can take place on your Hadoop cluster. Because of the parallelization nature of Hadoop, you get a lot of processing power for those transformations, which, let me try to go back a slide here, which is, I'll elaborate more on in a couple of points here. So another good use for a Hadoop cluster is it gives you an opportunity to archive some data. So, within Sears, on a lot of our operational systems or even in our data warehouse, we're constantly kind of battling with how much space we have. And so in a lot of cases, we will archive that data either off to tape, or sometimes we'll find some users, they know that we're going to be purging data, so they might make copies of it and store it on our shared drives and whatever. And, of course, the problem with those archiving efforts is that then the data is not really readily accessible. But because of the cost-effectiveness of Hadoop, you can actually archive that data on Hadoop, and really kind of keep it forever. And, of course, the beauty of it is that then it is accessible to users who might find a need for that older data. Obviously, you can use your Hadoop cluster to do analytics and deep analytics against the data that you've stored in there, either in your enterprise data hub or with some of the archived data that you're keeping. And then we also use our cluster for operational processing. So I had mentioned earlier about being able to transform data directly out of your enterprise data hub. So we actually do a lot of our ETL processing right on the Hadoop cluster from that base data. We've also migrated a number of mainframe and distributed batch processes onto Hadoop. Because of the nature of Hadoop, it does batch processing quite well. And we primarily, like, one of our repeatable use cases are to take COBOL batch mainframe programs and convert them to PIG and run them on the Hadoop cluster. And then another opportunity you have is any kind of like high disk consumption or high CPU consumption applications are also good candidates for Hadoop. Again, because of the parallelization within Hadoop and the fact that, depending on how big your cluster is, in our case, our cluster is approaching 500 data nodes. So that means you have 500 machines that potentially could run some of these like high CPU applications. And from my experience within our company, a lot of times those aren't applications that you want to run on a continuous basis. A lot of times it's just one-off analysis type work that you want to do. Maybe you write something sort of quick, load all this data onto Hadoop, and then run it, and then pretty much destroy, everything once you've gotten your answer.
Andy, we got a couple questions coming in. Speaking of the data hub, how long would you say it takes to create an enterprise data hub within an organization?
Well, it kind of depends, obviously, on how much data your organization has. In our case, we're sort of doing it through, I guess we're doing it on an opportunistic kind of basis. As projects come along that want to use Hadoop, we're getting them involved with our enterprise data architects, to actually help create the enterprise data hub. So it's an ongoing process. It's probably actually going to take us years. But if it's something that's like an approved project for your organization, you could probably, and depending on the size, you could probably create a pretty sizable enterprise data hub in a matter of months.
Okay, great. We got another question here. You're talking about analytics and deep analytics. Can you elaborate more on what the difference between those two are?
Sure. So obviously, a lot of organizations do analytics, and they pretty much use standard data warehouse platforms like Teradata and Netezza. I know a lot of organizations also do some of their analytics in like SQL Server or MySQL databases on a smaller scale. And of course, there's a number of business intelligence tools out there that interface with a lot of the common relational databases or data warehouse platforms. So that's analytics. Deep analytics is where you're working on much larger data sets that those infrastructures really couldn't handle because of the volume. The other definition on deep analytics is that you're doing very complex algorithms on those large sets of data. And again, a Hadoop cluster is very appropriate for those deep analytic type problems because it can handle the larger volumes of data, and because of all the CPU capacity that's available to you, it also handles the more complex analysis and algorithms that could be written for deep analytics. So let me move on here. So again, if you're faced with trying to make a business case for doing a Hadoop project within your organization, a lot of the benefits that you can look at are potentially lowering your costs and reducing your processing times. So on the lowering costs front, obviously Hadoop is an open source software package, so it can pretty much be downloaded for free. You do need to have staff available that can set up your hardware, set up the software, pretty much know some of the internals of Hadoop so that it can be tuned and so that it runs efficiently. The other thing I want to mention on this is that when it comes to the data nodes, which is kind of the critical mass of any Hadoop cluster, we have a reference architecture where I use the word frugal commodity hardware. Because of the fault tolerance and resiliency in Hadoop and the fact that you've got 3 replicas of the data, we've sort of designed our data nodes to fail, if you will. So our data nodes have a single power supply, a single NIC card, so we've been able to sort of eliminate some of the redundancy in the data nodes to drive the cost of that equipment down. Because within a Hadoop cluster, if one of the data nodes fails, the Hadoop ecosystem will automatically fail over to a data node that has the data. And for the most part, the end user or the batch job that is trying to access that data, it doesn't abend, and for the most part, it doesn't really even know that we've had a data node failure. It just continues to run. It might take a little bit longer because it's got to go through some failover and restart the process again on the new data node for that block. But for the most part, the failure is transparent. Now, the master nodes in the client node, if you think back to that graphic that I had earlier in the presentation, those are a little bit more of single points of failure. So for those particular machines, we do make them a little bit more fault tolerant in and of themselves. So they have dual power supplies, dual NIC cards. We actually would purchase, support from the hardware vendor on those machines because they're a little bit more of a single point of failure and more critical to the operation. But again, you can really drive down your software, your hardware, and your ongoing maintenance costs for a Hadoop cluster compared to traditional computing platforms like, again, your traditional data warehouses, Teradata and Netezza, or if you're purchasing like a SQL server, from Microsoft, Hadoop is a much cheaper computing model. And then with regards to reducing processing time, again, because of the parallelization within a Hadoop cluster, we've found that we've seen a lot of processing time benefits from taking some of the ETL jobs that we would run on our ETL platform, which, again, within Sears, we've actually used data stage. I think we've had some ab initio in place, but which, of course, have licensing fees. And putting that onto Hadoop and leveraging the parallelization within Hadoop cluster has taken some ETL jobs that have run hours down to just a few minutes. Because, again, a lot of times in your ETL environments, that work is kind of single-threaded through and not parallelized across all the data nodes, like in a Hadoop cluster. We've also taken a lot of mainframe batch jobs, as I've mentioned earlier, and ported them down to our Hadoop cluster, and we've seen a lot of processing time reductions by doing that. Again, it's the same sort of thing. It's really taking advantage of the parallel processing within a Hadoop cluster that you don't necessarily see in a mainframe environment. And of course, if you can reduce your batch windows and get your processing done quicker, that kind of opens the door to a few things. Might mean that you can potentially react to some things faster within your business, and or you're freeing up computing cycles on some of those other computing platforms to use for other things. So that's pretty much it for lowering costs and reducing processing times. Again, I was talking a lot about how we're reducing our ETL footprint and moving it over to Hadoop. And so this is just kind of a little graphic of bringing the operational source data into our enterprise data hub. And then as various systems need that data, instead of either waiting for it to be transformed, basically they can just kind of come into Hadoop, into the enterprise data hub, transform the data when they need it, which would mean that they're getting the most up-to-date data in the data hub, and either push it out to a reporting system, or maybe it's a system that needs sales data that's doing replenishment forecasting or whatever, or onto specific use data customers who are using it for analysis for various things. Again, I've talked an awful lot about the fault tolerance of Hadoop, and I think especially in a traditional enterprise where, companies are used to, purchasing software and purchasing maintenance on that software and purchasing hardware and purchasing maintenance on that hardware, there might be some reservations about going to open source software with, kind of stripped down commodity hardware. But again, because of the fault tolerance and resiliency of the Hadoop ecosystem, it really enables the organization to move forward with this technology where it kind of presents little risk to the organization. So I did describe that when a data node fails within a Hadoop cluster, the Hadoop ecosystem obviously recognizes that, and then it fails over to another data node that has that data on it, and to the end user or the batch process that's running, it doesn't really miss a beat. It just continues to go. Whereas obviously in some of your more traditional type computing platforms, you're going to get a failure. If you lose a node in a Teradata environment, usually the way Teradata architects their data warehouse platforms today, they have failover nodes, but the database, the Teradata database, does take a restart. It's all automatic, but it will actually take a restart and interrupt work. Netezza is pretty much the same way. And then, of course, if you're sort of on a single instance of a SQL Server or MySQL database and you have a hardware failure, you're going to get an interruption of service. So, again, the Hadoop ecosystem, it's kind of designed to fail, and then you do put a lot of emphasis on where you do have single points of failure within a Hadoop cluster, which would be the master nodes or that client layer. So, all right, and then I've just tried to document some direct benefits and some indirect benefits. So said another way, these would be hard benefits and soft benefits. But from a hard benefit or direct benefit standpoint, again, because of the open source software and the more stripped down commodity hardware, Hadoop environments are pretty cost effective to build. And when compared with some of your more traditional type processing environments should be cheaper for the same amount of processing power or more processing power. Obviously, you'll get faster processing times out of a Hadoop cluster. The other thing about a Hadoop cluster is the ease of scalability. So we, 3 years ago, actually started our Hadoop cluster out at about 50 nodes. At least it was at 50 nodes by the time we started really and called it production. And we've since grown it up to close to 500 data nodes. And what's kind of cool about Hadoop is that you can light up those additional servers, change the configuration files on within Hadoop, and Hadoop will just automatically start using those new nodes. So you can add additional machines to a Hadoop cluster without taking an outage. That's not true in any of the other data warehousing platforms that I have experience with. And again, the other thing is I've talked a lot about how our data nodes are kind of designed to fail. When they do fail, obviously the work automatically switches over to available nodes. But, once we fix that data node, who knows, maybe a hard drive went out, maybe one of the power supplies went out. Once we fix that node, we basically turn it on, it rejoins the cluster, and the Hadoop ecosystem will just automatically start using it. So again, there's a lot of ease of scalability with Hadoop. I talked a lot about the fault tolerance of Hadoop. Quite honestly, our production Hadoop cluster is pretty much available like 99.99% of the time. When we do have these minor data node interruptions, obviously we get folks in to fix it as soon as we can, but it doesn't actually stop the work, and there's no interruption of service to our end users. And again, with our enterprise data hub, if you can take your operational data, take it as raw as possible, because of the cost effectiveness of Hadoop, you should be able to save all the data. One of the things that we've done within our data warehouse environment at Sears is we've actually reduced the amount of data that we save from a lot of the operational systems because we didn't have the disk space to store it. But with Hadoop, you actually have a very cost-effective platform and can keep as much data as you want for as long as you want.
Andy, before we move on here, we've got a couple questions relating to the fault tolerance of Hadoop. The first question, in the Hadoop cluster, how many data nodes can you lose before it presents a problem?
Well, it depends on the size of your cluster. So we actually have built some relatively small clusters. So if you have a cluster that's, say, that has 20 data nodes, and you lose a node, that is basically 1/20th of your cluster. So you'd probably be okay with that. But as you started to lose maybe up to 5 nodes, I'd probably start to get concerned and want to start addressing those failures kind of quickly. In our cluster, again, approaching 500 data nodes, if you lose 5 nodes, it's probably not that big of a deal. We've got enough mass and critical mass there that we wouldn't have to worry about it. So it does depend on the size of your cluster with that.
Okay. The second question here is kind of a two-part question. First is, how long has Sears had Hadoop in the environment? And in that time, has there been a correlation in the reduction of incidents or failures that impact service to the clients?
So we originally started in late 2010 with Hadoop. And again, actually, we started researching Hadoop in late 2010. I believe that we had it productionalized by May of 2011. And again, that was with 50 nodes. And since then, we've continued to grow the environment. And the answer is yes on the, have we seen the service interruptions decrease? One of our first applications that got onto Hadoop happened to be our pricing application. And really what drove them into Hadoop is they really wanted to kind of do that deep analytics on large volumes of data. And the company just couldn't afford it on your more traditional type data warehouse platforms. And so they moved on to Hadoop. Prior to them being on Hadoop, they were running all sorts of different technologies, and they had a number of single points of failures that made their processes kind of unreliable. They had a hard time, a lot of times, meeting their SLAs. So with Hadoop, one of the things that we do find is that that even as we add more data to their processes, because of the parallelization, it actually keeps their runtimes pretty consistent, and they've been able to meet their SLAs. Matter of fact, I don't even remember the last time anybody was complaining about missing SLAs on the Hadoop platform. So yes, we have seen less service interruptions with the Hadoop platforms. And, I'm not going to say that we don't have any, but a lot of times, definitely we lose data nodes, maybe a couple of months. Again, that's no service interruption to the client. It's sort of those single points of failure layer, the master nodes. And we have had some times where we've had some problems with the name node where we've had maybe a 2-hour outage. The good news about that is that once we did restore service, we were able to catch up any processing that was behind very quickly. So.
All right, thanks.
All right, that's it for those questions?
Yep.
All right. All right, then the indirect benefits. You're able to keep a lot of data on a Hadoop cluster that maybe you haven't had the luxury of keeping before within your organization. And just as an example, we at some point the central Hadoop team decided, hey, let's keep a snapshot of the inventory data. So we took our retail inventory master file and started loading it into Hadoop on a daily basis. And when actually the pricing team realized that we were sort of keeping a snapshot of daily inventory, they started leveraging that because it's data that they never had visibility to. And so one of the questions they were able to answer, because we actually had that snapshot of daily inventory, is they could now assess when product didn't sell at a certain price, whereas before we would keep track of like when, how many units would sell at a promotional price or at a clearance price, but we never really kept like, what products aren't moving and then what price are they at. So they were able to utilize some of that information to ask questions that they could never answer before. And then, of course, you can keep your data for longer periods of time, maybe even forever, which could lead to more accurate, forecasting for replenishment or, more accurate analysis for things that, having longer periods of data, you might be able to do better forecasts in the future. Again, on our data warehouse platforms, we pretty much would start purging things that were older than 3 years old, but with Hadoop, we're actually keeping that data now. And it gives you the ability to do more one-off, large analysis efforts. So there have been times, in my experience with our data warehouse platform, where like our marketing department would hire somebody and they'd come in and they'd say they'd need a couple of terabytes of space to do some analysis, either on sales data or campaign. They'd need it for like 3 months and then they'd want it to go away. Well, with Hadoop, we actually have the luxury of kind of giving them that space and and the processing power to let them do their analysis. And then, of course, when it's all over, we can just kind of blow it away. So some roadblocks that some people might hit while they're trying to get approval to, spend some money for a Hadoop cluster. Hadoop isn't enterprise ready. Well, again, I think for a lot of the work we've done here within Sears, we've proven that it is enterprise ready. That it's not secure. It is secure with that client layer that we've kind of put on top of our reference architecture. We're able to secure our environment as well as any other enterprise system environment. From a who will support Hadoop standpoint, again, obviously you would need to train individuals within your IT organization to support Hadoop. Obviously, there are many organizations out there that do train Hadoop. Actually, MetaScale is one of them. And as a matter of fact, we're going to be offering a Hadoop developer training in the Chicagoland area on August 19th. And we can give you more specifics on that in a few minutes. Other options there are you can go with companies like Cloudera or Hortonworks. They will actually come in and help you train and set up a Hadoop cluster. You can also buy support from them, but it's really just kind of the core Hadoop support, and you can open tickets with them. But a lot of times it's not like a day-to-day support where they will log onto your Hadoop cluster and fix any problems that you might have. Although that's something that MetaScale also does. Hadoop is not for mission critical or for other critical work within your organization. Again, we're actually using it for very critical work within the Sears organization, and because of its fault tolerance and the Hadoop ecosystem, it's really quite a reliable processing platform. Hadoop cannot do what your distributed relational database models do. That is true to some extent. There's a lot of things that Hadoop cannot do that a relational database does, but you need to be cognizant of your use cases that you're going to and your functionality that you're going to put on Hadoop. There's a lot of things that Hadoop does very well, and I've outlined most of those things in this white paper in this presentation. Lack of management tools for Hadoop. Again, you don't have the full suite of management tools that you get on like an IBM mainframe or even in some of the distributed environments that exist today. But there are actually a lot of open source management tools for Hadoop. We're using a lot of them internally to Sears, and the market is becoming more mature every day with regards to those management tools. The maturity of backup and disaster recovery solutions for Hadoop. Actually, we have a methodology on how we do backup and disaster recovery for our Hadoop clusters, and it really involves, we've got a separate backup cluster that we back the data up to every day, and then from the backup cluster, we actually will siphon off, I'd call it, data to go to a disaster recovery cluster, although that has to be driven by the applications that run on Hadoop and driven by their business continuity plans, mainly because our disaster recovery cluster is nowhere near the size of our production cluster. So, we rely on the diligence of the application teams to develop and document their business continuity plans to determine what data gets moved over to the disaster recovery machine. And then another roadblock might be, do you have the skills internally within your organization? And again, obviously that would entail some training, or again, MetaScale actually offers services to manage a Hadoop cluster. So how much time do we have left?
Got about 5 more minutes, Andy.
All right, so I think instead of talking about some of the risks, so again, if you're making a business case for Hadoop in your organization, and you might have to take it to a committee for approval or upper management for approval, you know, this risk slide sort of leverages my knowledge of project management. I'm actually a certified project manager from PMI, and so, you know, demonstrating to the powers that be that Hadoop can help you either, you know, mitigate or transfer or avoid risks in your organization might be a good angle to take when you're putting together your business case. And really, Hadoop can address a lot of the various risks that can be encountered for an IT department. You know, again, because of the resiliency of Hadoop, you know, it's reducing outages. When there are some minor blips in a Hadoop cluster, obviously the processing continues to go. It helps you better meet your SLAs. And then in some cases, with regards to transferring risks, you can actually contract with either MetaScale to provide these services or some of the other vendors out there to help, you know, transfer the risk of running your Hadoop cluster. So, and again, I didn't want to spend a whole lot of time on that. We could, you know, get into more detail on that in other sessions, I suppose. I did want to go through, I put together a sort of a plan A and a plan B. And so plan A is just a way to get started with Hadoop. And really just about anybody could do this. Basically, the idea is where you create a very small cluster. You might be able to leverage some surplus equipment that you might have, even older surplus equipment that you might be targeting decommissioning. Or maybe you do buy some fresh, you know, a small quantity of machines to build a small Hadoop cluster. Once you have the Hadoop cluster built, you could identify some small, low-impact use cases that you could sort of try Hadoop out for. You know, maybe it's some marketing analysis, or maybe it's some small batch process that is continuing to miss its SLAs, or maybe it's on a platform that is, you know, giving you a lot of pain points or whatever. But my advice on that is sort of, you know, make sure that whatever use case you pick is a good use case for Hadoop to ensure success. And then that could, you know, that could be sort of maybe a proof of concept type approach. So that's plan A. Plan B is where you're going for something a little bigger, where maybe you've got a larger initiative that you want to target Hadoop for. And some of the considerations that you might have for success in that kind of an endeavor is, you know, educating the people that have to approve it on what Hadoop is, and then also talking about, you know, what your success story is going to be. Actually doing plan A with a small, you know, sort of trying Hadoop out is a good segue that you could reference on, you know, how successful you've been with Hadoop. You know, also identify the pain points that you're going to address with Hadoop. Again, for instance, you know, attempting to implement a Hadoop solution so that you can consistently meet SLAs, or just outline how Hadoop might fix some of the pain points that you're seeing within your organization for certain functionality. Other things to consider is you pretty much want to have a rock-solid hardware architecture, one that also plans for growth. At this point in time, we're actually growing our cluster a rack at a time. So, you know, whenever we're adding additional equipment into our Hadoop cluster, we're doing it on a full rack. So obviously that means that in our data center, we've got to have the real estate available, the floor tiles, so that I can continue to add racks. in addition to the environmentals, which would include power, making sure that your location has enough air conditioning to cool, as well as network capacity. You need to consider your software support model. Are you going to do it internally, meaning you have to train your staff, or externally by contracting with like MetaScale to do it? Data architecture is also something that's important within a Hadoop environment. Hadoop doesn't really do well with your traditional third normal form relational models. It likes a much flatter data model, so a denormalized model, so that's a consideration. You'd want to have data architects, well-versed on Hadoop and how it processes the data to make it successful. Data layers within our environment, and we advocate this for MetaScale customers. We have like an incoming layer. From incoming, we move it into like a gold layer, which is where our enterprise data hub lives. We have some work layers, as well as a layer where if somebody might do a transformation to data that is only consumable by a given department or a given application, so we sort of give them a space where they can put that data for it to persist. Obviously, if you're making a business case, you'll need to, keep an eye on your costs, your hardware costs, your software costs, and your personnel costs. I guess you could also add any outside vendor costs to that. And then, of course, you'd want to outline your benefits. Where are you going to see cost reductions? Where will you see reduced processing times so you can meet SLAs better? If you're going to be building a data enterprise data hub, how is the organization going to benefit from that? Also, you might be able to target being able to get new insights through analytics you've never been able to do before. And then just the opportunity to keep data, maybe data you haven't been able to keep in the past, or keeping data longer periods of time than you've been able to. And again, potential risks you might run into is your organization's knowledge of Hadoop, building the expertise within your organization, either to build Hadoop and or use Hadoop, so skills to develop your Hadoop solutions. And then also, again, if you're trying to get approval, you need to sort of break down that perception that Hadoop might not be ready for prime time in a big organization, but it really is. We're doing it every day here at Sears. So that's the presentation.
Oh, great job, Andy. We've got lots of questions here, but we are kind of coming up on time. I think Andy could talk all day about Hadoop and the enterprise. Try and get to one more question here. You were talking about the skills and the MetaScale training. Can you go into a little more detail about what skills are required, and then also how the training can play into that?
Sure. So, well, again, I actually run our Hadoop infrastructure team. So to build a Hadoop cluster, you actually need a multidiscipline team. So I actually have a number of resources that were Linux administrators. I've actually got some resources that used to be database administrators, as well as one individual that knows a lot about middleware. I also have a network engineer on my team because of, you got to interconnect all those data nodes somehow. So it really does kind of take a cross-functional team to kind of bring together a nice, robust enterprise Hadoop cluster. In addition to that, your organization will also need to know how to develop applications for Hadoop, and that's kind of where the MetaScale developer training comes in. The MetaScale developer training kind of focuses in on an overview of what Hadoop is, how it works. So the whole parallelization is sort of a paradigm shift for most developers. But Hadoop does sort of abstract the developer from that. But they really do need to kind of know under the covers what's happening. it also goes into a lot of the tools that are available to a developer within a Hadoop ecosystem, like Hive, Hue, Pig. I think it gets into HBase and kind of drills into how to write functionality using those tools. And again, that's going to be offered in Chicago August 19th through the 22nd. And the name of it, we're partnering with Caliber Data Training. And to sign up for that training, you can go to their website. It's www.caliberdt.com. So that's CALIBERDT.com.
All right, thanks, Andy. Sorry we couldn't get to everybody's questions, but if you go to the next slide, we'll have our contact information. You can contact us at contact@metascale.com or visit our website at www.metascale.com, and we'll be able to answer any questions that we didn't get to or any other questions you may have. And like we said, this webinar correlates to a white paper that Andy developed. And part of that white paper is an actual outline or framework of a plan for making a case for Hadoop in your organization. So be sure to download that if you haven't already, and feel free to contact us and go through it, and we can help you out in any way you may need. So thanks again, Andy, and thank you for everyone that attended. We also have a webinar on legacy modernization with Hadoop coming up August 14th, so be sure to sign up for that if you haven't already. Thank you, and have a great day.
Thank you.